What do you feel when you see a tree? I actually kind of prefer trees without leaves, which is maybe a little bit peculiar. And I think that's probably because of my career as an astronomy researcher studying the largest system in the universe, arguably, which is called the cosmic web. And so I hope that my probably sort of unusual perspective can be interesting or helpful for you too. Leonardo da Vinci is well known to everyone, I'm sure, and he actually studied everything, including trees also. So this is a drawing that he made illustrating one of his few quantitative theories. It was before quantitative theories were cool. It was about a century before Galileo and Kepler. This tree drawing illustrates a theory that the sum of all of the cross-sectional areas of the branches of a tree equals the cross-sectional area of the trunk. And so it's kind of like string cheese incident in which you peel off some branches and maybe subdivide some of them, but all the strands from the trunk of the string cheese end up somewhere. Leonardo da Vinci, in the next sentence, so it discussed river networks with very similar language. There's a strong suggestion that he was using the power of analogy between different systems to make insights into them. My main point of this talk, besides telling you a little bit about the cosmic web, is that analogy is tremendously powerful in science. So here's another river network. This is the Mississippi River Network. It covers most of the United States. And it has an official source up there in the north, but actually I think that's pretty artificial. It's really the whole thing that constitutes this river. That Chicago is just over the ridge toward the Great Lakes. So that'll come back. And the cosmic web, this is a picture illustrating how galaxies come together and how flows happen in the universe. So right there is a bunch of galaxies that maybe you could see if there weren't pesky stars in the way in the night sky, and if your eyes were super big. In the middle, points are shown with their full network between them of gas and dark matter, and then at left is shown some flow lines which show how the matter assembled together. That started happening immediately after the Big Bang. There were some patches with a little bit more matter than others, and those assembled more and more matter through these filaments of the cosmic web, and those filaments have a strong analogy to rivers on a landscape. We're actually still flowing through this thing. This is a structure called Laniakea. It's called a watershed supercluster. We actually use the word watershed, even though it's not water. But there's a tiny bit of water in there, but it's all basically gas. One way to understand what's going on here is that, well, the universe is expanding, as I'm sure you know, but if the universe suddenly halted in its expansion, all these 100,000 galaxies, or approximately, would slowly drift toward the center and form a huge supergalaxy. One thing that I'm trying to do now with a student named Glimpse Pandy is to understand this cosmic web a little bit better by just poking at that connection between the cosmic web and river networks, which is a well-known correspondence among people who know about the cosmic web, but it's not something that's really rigorously been established. So what we're doing is inducing what we call an intergalactic rainstorm in the universe. Well, not our universe, but a simulated universe. We don't expect that to actually have happened in the real universe, but basically we're doing the same thing that I mentioned with Laniakea, which is to halt the expansion of the universe, which causes things to rain down and for clustering to advance. This shows after the rainstorm, and this is before the rainstorm. So that you can see that some of the stuff moves a little bit and some of it gets bigger. We expected that the strands they're called the filaments between the blobs, which are the cosmic rivers, would swell with water a little bit, in analogy with the terrestrial rainstorm, and indeed that's what happens. from cosmic scales back down to earthly scales, and also connecting more with humans, I think is important. We humans and scientists especially maybe try to think of ourselves as apart from nature, but we're really part of nature, and we even flow around. It looks kind of like a circulatory system. This shows the truck traffic through Illinois. And I think it really looks like there's a heart in Chicago. There are some metaphors maybe to be drawn from that. And actually, I think it's interesting that these networks interplay with each other. So Chicago is such a big hub of lots of networks because it's right between the huge watershed networks that used to be crucial for transportation in the 19th century of the Mississippi watershed and the St. Lawrence Seaway. The flow network that is literally closest to my heart is the one that includes my heart, which is the circulatory system. So I think it's amazing, and I don't usually think about it. Most people don't think about it very much, but the blood actually goes to every cell in our body, and there's a little capillary near every cell of our body, which is crazy, actually, I think. The surface area of the circulatory system is approximately 3 tennis courts worth, which is huge, not quite as big as a galaxy, but it's pretty big compared to human size. Also, the lungs are pretty crazy. They're similarly super branching. The trachea to the places where the oxygen is actually exchanged with the blood takes about 23 branchings. So 23 isn't a huge number, but a typical tree only has like 5 or 10 branchings. So not branches, they may have more branches, but they branch like 5 to 10 times, but this branches 23 times. So what I want you to do in a little bit is to take a deep breath. I'm going to do that also. And maybe think about some of these systems that are related to the lungs operating. So, for example, you can think of water being pulled up through a tree and up into the sky through lots of branches, or raindrops falling on mountains and slowly going downhill until they meet in a valley and ultimately going out in a river, or some hydrogen atoms or molecules way out and ridiculously farther than any human will ever go, very gently drifting over eons through the universe, through gravity, and ending up in a filament, which joins with some other filaments, and ultimately going into a galaxy, maybe our galaxy, and our planet, and maybe your body. So, okay, we're going to take a deep breath. So interconnectivity is a big part of a lot of spiritual and especially indigenous traditions. I think it's the source of not just knowing about how to operate in the world, but it can be the source of awe. I don't just look at a tree by itself, but I think of all the systems, or some of the systems that it's related to. It's important to feel awe. Awe has been shown through the relatively new science of awe to enhance some good things about society, such as empathy and generosity, and to suppress some bad things, such as tribalism, that of course there's way too much of. Awe that's linked with science can be even more powerful. So that's one reason why I'm poking at these connections between fields. So some of these systems and cosmic things can be mind-blowing, but I think it's also mind-blowing that we can actually understand these things through science, even though we may need our minds to be not entirely blown to do that. Thank you.